Alrighty, friends, let's take a look at the second part of 7.4. We've actually done this in the past, finding the inverse. We would notate it like f to the negative 1 power, and we did the same things. We switch the x's and y's and get the function alone, which is kind of tricky. In this case, the two things we're particularly looking at are logs or base to a power, and the log might be an ln instead of an log. So this is going to be the thing that's different, because what we have to, like in the past, we would use adding to get rid of subtracting or squaring to get rid of square rooting. That all makes sense. What we have to start to figure out now is at this point, when we have a log and need to get rid of it, we need to write it as an exponent. And when we have this exponential, we need to write it as a log. So that goes back to the previous lesson, where if I have log of some base and then it equals a power, I can rewrite that as that base to a power and then come back around and have that be the answer. So these are the two forms that I have to go back and forth between. So, and then you just get y alone. So let's go through one together. So the first thing I have to do is swap my x and y. So I put the x where the y was and the y where the x was. Since this is exponential, I need to rewrite it as a log. So log, and then the base is whatever is raised to the power. So in this case, that's a 6. So the 6 goes in the basement. It's very loud in here. And then the power always goes on the other side. So this is how this would play out. Log base 6 of x equals y. And then you're supposed to get y alone, except y is already alone. So you're good to go. One of the things you want to look at is if you started with an exponential, you should end with a log. If you start with a log in the problem, you should end with x in the power, because they are math inverses of each other, like math opposites. So like looking at this problem, I see there's an ln. That's log base e. So when I'm done, I should have e to a power. So like up here, I started with 6 to a power, and I ended up with log base 6. So 6 was my base here, and it's my base here. In this problem, e is my base. That's why it says ln. And so when I'm done, I'll have e as the base raised to a power. So let's go x equals ln y plus 3, because I am swapping the x and y. And then now I have a log, ln. So I'm going to write the e here to make myself remember that that's what it is. I'm going to put it to the power, which is always on the other side. And then it'll come back around to equal this. Now in this particular problem, y is not alone, but it's an easy fix. I take 3 away. So my inverse is going to be e to the x power minus 3, which makes sense because up here I have adding, so I expect subtracting. Up here I have a log base e, so now in the end I have an exponent of base e. Now my dog's going to take a really loud drink. This is going well so far. So I'm going to put an x here where this y is. I'm going to put a y where the x is. And before I can do anything, I need to get the exponent part alone. Seriously, that is so loud. So I'm going to start doing that by adding 7. Cinder. Okay, keep drinking loud. Hey, yeah, Dolly, make sure you drink loud too now. I'm making a video, and you're being really loud. All right. So I still need to get this part alone, but it's multiplied by 5. So to get the 5 out of there, I'm going to divide. Finally, I have my 3 to a power. So I know that my final answer should end with log base 3, because the 3 is the base of my exponent. So I'm going to rewrite this. You write log, then you put the base in the basement. The power always goes on the other side alone. And then whatever else you got in the problem basically ends up in this position. So I ended up with a log base 3, which is what I expect since I started off with an exponent of base 3. Up here I had a minus 7, so down here I'm glad to see a plus 7. Up here I had a times 5, and down here I have divide by 5. So everything I have at the end is the math opposite of what I had at the beginning. So if you look at it that way, you can look and say, hey, this has a +8. Hopefully I have a -8 in my problem. This is divided by 3, so in the end I should have a times 3. This is a log with 4 in the basement, so I should end up with 4 as the base of an exponent, meaning 4 to some power. So let's do the thing. X equals 1/3 log base 4 of y plus 8, because I swapped the x and y. I now need to get this part alone. So I need to get rid of the 8, so I'll subtract it over. X minus 8. I always have to get either the log or the exponent part alone, so I'm still trying to get this alone. So to get rid of the 1/3, I'm going to times it by 3, and I'll multiply this whole side by 3. You can either leave it like that, or you could distribute the 3 and make it 3x minus 24, whatever makes you happy. And then that's going to equal log base 4 of y. Well, now that I have a log alone, I rewrite it as an exponent. I start in the base. This whole thing, 3x minus 24, becomes the power. And then I come back around to get that y. And so in the end, I'm done. And I had a +8 up here, so it turned into a -8 down here. You can see the 24 in the problem, but that's because I multiplied everything by 3. And then I ended up with an exponential with 4 as the base, which is what I expected since I started with a log as a base. So the idea of this is just that logs and exponents are math opposites. So in here, in your homework, oh, this is the wrong homework packet. Okay, we're just gonna be done. So hopefully that'll help you get through that 7.4 day 2. Bye guys.